number 3, we've got a little more difficult function to deal with for our derivative. We're going to have to use product and chain rule here when we take our derivative. So the derivative, we take the derivative of the first part, we get 2 times 4x minus 3 to the first, times the derivative of the inside, which is 4, times the regular second function, so 3x plus 1, 2, plus regular first function, so 4x minus 3 squared, times the derivative of the second function, we get 3 times 3x plus 1 squared, times the derivative of the inside, which is 3. So we can figure out when this is 0. We're going to clean things up a little bit. We end up with 8 times 4x minus 3 times 3x plus 1 cubed, plus 9 times 4x minus 3 squared times 3x plus 1 squared. And now we want to go ahead and try and factor some things out. So when we do that, constants, there's really nothing we can factor out of that. But they both have a 4x minus 3. So we can take out the lowest degree, so just 4x minus 3 to the first. Then we can take out a 3x plus 1 to the lowest degree, which is second. So we can take out a 3x plus 1 squared. And then figure out what we're left with. So when we take this first term divided by this, we're left with an 8 and the 3x plus 1. The second part, we're left with a 9 and a 4x minus 3. So we can distribute and combine some like terms here inside of this set of parentheses. We get 24x plus 8 plus 36x minus 27. So we've got our 4x minus 3, 3x plus 1 squared. And then if we combine like terms over here, we get 60x minus 19. So we're going to end up with 3 critical values. We get x equals 3/4, x equals negative 1/3, and x equals 19 over 60. So we'll put those on our derivative number line here. So negative 1/3 all the way to the left, 19 over 60, and 3/4. So for this one, let's look at values we can plug in. To the left of negative 1/3, I'm just going to put negative 1. Between these, I'll put 0, 1/2, and 1. So I'm going to use this form of the derivative, this factored form, to figure out our number line. If I put negative 1 in, this first one here is going to be negative. This is always going to be positive because of the squared. So it doesn't matter what we put in there, that's always going to be positive. If we put a negative 1 in here, we're going to get a negative. So negative times a positive times a negative gives us a positive. If we put 0 in, we're going to have negative, positive, negative again. So here it's not changing. So this is one of those situations where it's not a minimum or a maximum here. It's not alternating like a lot of the ones that we've seen. All right. If we do positive 1/2, 4 times 1/2 is 2 minus 3. That's still negative. This is still positive. 60 times 1/2 minus 19. That's going to be positive. So now this is negative. Here this is changing. This is going to be a local max, right, from positive to negative. Then if we put positive 1 in here, this is going to be positive. That's always positive. This is positive. That's positive. Here we're going to get a local min. So we have a local max when x is 19 over 60. And we have a min when x equals 3/4.